Good morning, students. Today we will read, that is, inequalities. So, an inequalities involve either less than or equal to. How to solve an inequality? Suppose an equation of a straight line is 3x minus 4y is equal to 12. So, this is an equation of straight line. So, it is an equation and it is an inequality if 3x minus 4y is less than equal to 12 or 3x minus 4y is greater than equal to 12. So, how to draw these lines inequalities? So, if we consider this line 3x minus 4y is equal to 12. So, we can draw by taking 2 points, that is x and y. If x is equal to 0, y is equal to minus 3, and if y is equal to 0, x is equal to 4. So, the points, 2 points are 0, minus 3 and 4, 0. So, these are the 2 points. So, we can draw the line by taking x and y axis. So, that is x is 0, minus 3 and it is 0, minus 3, that is on y axis. So, that is point is 0, minus 3 and it is 4, 0, that is on x axis. So, we can draw this line. So, this equation is 3x minus 4y is equal to 12. So, this is an equation. So, if we make it an inequality, so for 3x minus 4y less than equal to 12. So, how we can plot this point? We can take a reference point which is not on the line. Suppose the reference point is origin, which is not here on the line, that is 0, 0. So, we can choose a reference point. We choose origin as reference point 0, 0 and we put x is equal to 0 and y is equal to 0 in 3x minus 4y less than equal to 12. So, obviously, we have 0 less than equal to 12, that is true. So, true means it lies towards the origin, and if it is false, it is away from the origin. So, if it is true, it is towards the point, and if it is false, it is away from the point. So, we can set this region and the setting part is 3x minus 4y less than equal to 12. So, this is inequality. We can solve this inequality like this. And if we choose, say, take another point, say we can choose, say, another point, that is 4 minus 5, say 4 minus 5 and put x is equal to 4 and y is equal to minus 5 in 3x minus 4y less than equal to 12. So, we have 12 plus 20 less than equal to 12, obviously 32 less than equal to 12, it is false. So, false means it is away from this point, true means it is towards the point, false means away from the point. So, we can say take any point on the plane, if it is true then it is towards the point, it is false, it is away from the point. So, next we take one more example. That is 2y minus 3 less than equal to 4. So, to solve this inequality, first make it as an equation. Let 2y minus 3 is equal to 4. So, 2y is equal to 7. So, y is equal to 7 by 2. So, y is equal to constant is a line parallel to x axis. So, y is equal to 7 by 2. So, this line is 7 by 2 and it is a line that is parallel to x axis. And if we consider the inequality, that is for 2y minus 3 less than equal to 4. So, this implies y less than equal to 7 by 2. So, for this inequality, to solve this inequality, again we choose a reference point which is not on the line. So, obviously origin is our reference point, it is not on the line, we can take a origin. So, we can choose origin, that is 0 0 and put x is equal to 0 and y is equal to 0 in y less than equal to 7 by 2. So, obviously there is no x term, only y. So, that is 0 less than equal to 7 by 2, it is obviously true. So, that means it is towards the point. So, we can set this region, that is y less than equal to 7 by 2. Similarly, we can take one more example. Say x less than equal to x greater than equal to 5. If we solve this equation inequality, so first of all we let x is equal to 5. So, this is a line parallel to y axis. And it is 5 units away from y axis, that is x is equal to 5. So, for this inequality we can choose a reference point. Obviously, we can choose origin 0 0, that is a reference point. So, if we choose the origin 0 0 and put x is equal to 0 and y is equal to 0 in x greater than equal to 5. So, obviously there is no y term, only x, that is 0 greater than equal to 5, it is false. So, false means it is away from this point origin. So, that means it is away from origin, and we can set this region. So, that is x greater than equal to 5. On the line it is equal to, one side is greater than and obviously the other side is less than. Next we take one more example, that is say mod x minus 4 is less than equal to 2. So, if we omit the modulus sign, so x minus 4 lies between minus 2 and plus 2. So, x lies between minus 2 plus 4, 2 plus 4, that is 2 less than equal to x less than equal to 6. So, we can plot this on axis, that is origin 1, take 2 points, that is 2 and 6. So, x lies between x less than greater than 2 and x less than 6. So, x is greater than 2 and x less than 6 equal to. So, the common region is our solution region. So, the solution region lies between 2 to 6. So, this is the solution region which lies between 2 and 6. Similarly, we can take one more example. Three x minus 1 modulus is greater than equal to 4. So, first of all we choose is, let 3x minus 1 less than 4, or we can consider 3x minus 1 less than 4, this is opposite of greater than equal to. So, this implies 3x minus 1 lies between minus 4 and plus 4. So, that is minus 4 less than 3x, minus 4 plus 1 less than 3x less than 4 plus 1. So, that is minus 3 less than 3x less than 5. So, minus 1 less than x less than 5 by 3. So, that means for the inequality 3x minus 1 less than 4, x lies between minus 1 and 5 by 3. And so, that is this origin minus 1 and it is 5 by 3. And for this inequality 3x minus 1 greater than equal to 4, we can just reverse the order, x less than minus 1, that is x, its reverse is x greater than equal to minus 1. X greater than minus 1, its opposite, x less than equal to minus 1, and the second part is x less than 5 by 3 and x greater than equal to 5 by 3. So, the solution region is x less than minus 1 means opposite side and x greater than 5 by 3. So, it has two different ends and there is no common person. So, it is this combination of these two parts. So, obviously, we can write the solution is x belongs to minus infinity to minus 1 union 5 by 3 to infinity. So, this is the solution region, or we can have the interval. So, till now we have one equations. Now, we consider two equations simultaneously and solve it. Suppose we have two simultaneous equations, that is 3x plus 4y less than equal to 12 and x plus 2y greater than equal to 6. And we have to solve this inequality. First, make it as an equation, that is 3x plus 4y is equal to 12. And the second equation is x plus 2y is equal to 6. So, we have two equations, 3x plus 4y is equal to 12 and x plus 2y is equal to 6. Now, we can draw 2 points or divided by 12, that is x by 4 plus y by 3 is equal to 1. So, we have x intercept is equal to 4, y intercept is equal to 3. Similarly, for the second equation we have x by 6 plus y by 3 is equal to 1. So, we have x intercept is equal to 6, y intercept is equal to 3. Now, we can plot these two equations. So, first one is point is x intercept 4 and y intercept is 3. So, that is 4 0 and 0 3. So, x intercept 4 means the point is 4 0 and y intercept 3 is, that means the point is 0 3. So, we can join this and this is equation 1. Similarly, x intercept 6 means the point is 6 0, y intercept 3 means the point is 0 3. So, we have 6 0 and 0 3. Is equation 2. So, we have two equations and we plot these two equations simultaneously. We choose a reference point which is neither of these two lines. Obviously, here origin is our reference point we can choose the origin 0 0. If we choose origin, the reference point, so you can have any, we can choose any point which is not on the line and put this point x is equal to 0, y is equal to 0 in 3x plus 4y less than equal to 12. So, obviously 0 less than equal to 12, it is true. So, for this first line, it is towards the origin. And for the second line, if we put x is equal to 0, y is equal to 0 in x plus 2y greater than equal to 6, that is 0 greater than equal to 6, it is false. So, false means it is away from origin. So, true means it is towards the origin and false it is away from the origin. So, what is this solution region? Solution region is common to both the region, which is common to both part. So, obviously this part is common, it is away from origin and towards the origin. So, this is the solution region. So, it is our this is our solution region. Next, we can take some more examples, that is solve x 2x minus y less than equal to 0. So, first of all, make it as an equalities. Let 2x minus y is equal to 0. So, y is equal to 2x. So, y is equal to mx is a line passes through origin. So, y is equal to mx is a line which is passes through origin. So, y is equal to 2x passes through origin. So, obviously 0 0 is on the line. And to find one more point, if we take x is equal to 1, then we have y is equal to 2. So, 1 2 is another point on the line. So, we have 2 points, one is 0 0 and 1 2 are on the line. Next, to plot the graph, So, that is origin 0 0. Next it is so we can plot this line, that is y is equal to 2x. And for 2x minus y less than equal to 0, that is y 2x less than equal to y. We can take a reference point that is not on the line. Here obviously origin is on the line, we cannot take origin, and 1 2 it is on the line. We can take any other point which is not on the line. Say taken point, that is 2 0, and this point 2 0 is not on the line, and it is a reference point. You can have any reference point that is not on the line, any of the 4 quadrants. So, if we choose the reference point two 0, then obviously if we put x is equal to 2 and y is equal to 0, that is 4 less than equal to 0, obviously it is false. So, false means it is away from this point 2 0. So, we can set the region, that is away from 2 0, and set the region. So, this is the solution, 2x minus y less than equal to 0. So, this is the solution region. So, we have graphically solved inequalities. So, inequalities are equations, inequalities are either it is less than, equal to, or greater than equal to. Now, we will take 2 or more equations. We have first initial 1 equation, then it is 2 equation, then we have 2 or more equations. Suppose it is x plus 3y less than equal to 12, 4x plus 5y greater than equal to 20, and x greater than equal to 0, y greater than equal to 0. So, this inequality has 4 inequalities. So, first put this inequality, putting inequalities into equalities. First we put inequalities into equalities, that is x plus 3y is equal to 12, and if we put x is equal to 0, y is equal to 4, and y is equal to 0, x is equal to 12. If we put x is equal to 0, y is equal to 4, and y is equal to 0, x is equal to 12. So, the point are 0 4 and 12 0 on, say this is equation 1. So, to draw a line we have at least 2 points. Now, the second equation is 4x plus 5y is equal to 20. This is equation 2. Subsequently, if we put x is equal to 0, we have y is equal to 4 and y is equal to 0, x is equal to 5. So, 0 4 and 5 0 on equation 2. So, for the first line we have 2 given points and for the second line we have 2 given points. Next, third inequalities is x is equal to 0. X is equal to 0 is y axis and y is equal to 0 is your x axis. So, x is equal to 0 is y axis, x is equal to constant is a line that is parallel to y axis. Similarly, y is equal to 0 is x axis, y is equal to constant is a line parallel to x axis. So, next we have to plot those 4 equations in a rough sketch. So, on x axis the maximum point is 12. So, we can take 1, and so first point is 0 4. And 12 0. So, this is inequality 1. And for the second equation, it is 0 4 and 5 0. Again it has 2 points. Then third equation is y is equal y axis. So, y axis is, and fourth equation it is x axis. So, we can number those lines accordingly. This is equation 1 and it is equation 2, y axis is equation 3 and x axis is equation 4. Now, for first quadrant it is positive positive, x positive y positive. Second quadrant is your negative positive. First quadrant x positive y positive. Second quadrant x negative y positive. Third quadrant negative negative, both x and y are negative, and fourth quadrant it is positive negative. So, x greater than equal to 0, that is positive, and y greater than equal to 0 is positive. So, these two combinedly represent positive positive, means it is first quadrant. So, we concentrate the graph on the first quadrant only, because x positive, y positive, that is positive positive, that lies in the first quadrant. So, we consider the graph only in the first quadrant. Now, for this inequality, x plus 3y less than equal to 12. Now, we can again choose a reference point which is not on the line, that is 0 0. So, if we put x is equal to 0, choose the origin 0 0 as the reference point and put x is equal to 0, y is equal to 0 in x plus 3y less than equal to 12, that is 0 less than equal to 12, it is true. So, that means it is towards the origin. Again 0 0 is not on the equation 2, second line. So, if we put x is equal to 0 and y is equal to 0 in the second inequalities, that is 4x plus 5y greater than equal to 20, that is 0 greater than equal to 20, it is false. So, false means it is away from origin. So, one part it is towards the origin and it is away from the origin, and it is in the first quadrant. So, we consider all those things combined together. So, what is the common region? So, out of all these RMRs, so this part is your common region because this is towards origin, it is away from the origin, and it is in the first quadrant. So, this is our solution region. So, this is the solution region. So, that means we solve two variables graphically by doing rough sketch, and the solution region is so we can take one more examples. Say solve 2x minus 3y less than equal to 12, x plus 4y greater than equal to 8, x plus 2y x minus 2y less than equal to 0, x greater than 0 and y greater than equal to 0. Suppose we have 5 inequalities. How to solve this? First, making inequalities into equalities, that is 2x minus 3y is equal to 12, equation 1, x plus 4y is equal to 8, equation 2, x minus 2y is equal to 0, equation 3, and x is equal to 0, equation 4, y is equal to 0, equation 5. So, we have 5 equations, and here x is equal to 0, y is equal to minus 4, and y is equal to 0, x is equal to 6. So, the points are 0, minus 4 and 6, 0 on equation 1. Similarly, if we put x is equal to 0, y is equal to 2, y is equal to 0, x is equal to 8. So, that is 0, 2 and 8, 0 on equation 2. X is equal to 2y, if you put x is equal to 0, y is equal to 0, and y is equal to 1, x is equal to 2. So, that is 0, 0 and 2, 1 on equation 3. So, x is equal to 0 is y axis, y is equal to 0 is x axis. Now, coming to inequalities, we can plot this 4 graph equations. So, that is 6, 0, so 0 minus 4, that is on y axis, and 6, 0 on x axis. So, this is equation 1. Zero 2 and 8, 0. And third inequality is 0, 0 and 2, 1. Then y axis is equation 4, x axis is equation 5. So, we have 5 equations and we mention accordingly. X positive, y positive, x greater than equal to 0 means x positive, y greater than equal to 0 means y positive. So, this two is first quadrant. Next, we choose any reference point which is not any of this line. Suppose it is 3, 3, which is neither of any of the line. If we choose x is equal to 3 and y is equal to 3, put in 2x minus 3y less than equal to 12, that is 6 minus 9 less than equal to 12, that is minus 3 less than equal to 12, that is true. And if we put x plus 4y greater than equal to 8, that is 3 plus 12, that is 15 greater than equal to 8, it is again true, and x minus 2y less than equal to 0, that is 3 minus 6 less than equal to 0, minus 3 less than equal to 0, again it is true. So, that means it is equation 1, it is towards the point 3 3, and equation 2, it is towards the point 3 3, and equation 3, it is towards this point, and it lies in the first quadrant. So, this is our common region, which is common to all those parts. So, this is our solution region. So, we can have inequalities that involves one equation or two equations or more than two equations. If it is one equation, then it is on the line, and it is two variables, that is on the plane. So, inequalities are, take one inequalities, that is x less than equal to, x lies between minus 3 and 2. If we solve this inequality, then it lies between two numbers minus 3 and 2. So, x lies between minus 3, x less than minus greater than minus 3 and x less than 2. Less than 2 means it is towards left side, and x greater than minus 3. So, this is our common region. So, this is our solutions region. So, we can express the solutions in form of intervals. That is, intervals are two types, one is open interval closed interval and semi open or semi closed interval. So, the solution of this inequality can be expressed in form of interval. If it is less than sign, then we have open interval. Open interval means we have a round bracket. It is closed interval, we can represent it in a square bracket. Semi open or semi closed, that is either one side closed, other side open, or one side open and another side closed. And for these solutions, x between minus 3 and 2, we have x belongs to minus 3 to 2. So, this is the solution. So, this is all about inequalities. So, inequalities can be solved in 2 dimension. If it is 1 dimension, that is on a straight line, we can express the inequality in form of interval, that is either it is an open interval or it is a closed interval or it is semi open or semi closed interval. So, what is semi open, semi closed interval? If a solution of mod x less than equal to 2. So, if we omit this modulus sign, then x lies between minus 2 and 2. So, x less than 2 and x greater than minus 2. So, this is the solution region and the sign is equal to, less than equal to. So, we can express it as a interval form, that is x belongs to minus 2 to 2 and it is a closed interval. So, closed interval, the sign is less than or equal to. So, what is difference between closed and semi open interval? So, in these points are called end points. Suppose we have a b is an open interval and it is a b is closed interval. A b, this is semi open or semi closed interval. So, what is the difference between open and closed interval? So, these are called end points. So, in open interval the end points are not included, that is A does not belongs to AB and B does not belongs to AB, but A belongs to closed interval AB and B belongs to closed interval AB. So, end points are included in the closed interval, but end points are not included in the open interval. Okay, thank you.